All right, welcome to Lecture 1 for Module 3, which we're covering North America this week. So just a quick recap of this region. We have about 355 million residents across what we're basically counting 3 countries, Greenland, Canada, and the United States. Greenland is an interesting one because while geographically speaking, it's more associated with the United States, culturally and politically speaking, it's actually more associated with Europe. I attended a talk probably a year or two ago by a geographer, and she was working for the Department of Defense. And apparently, she had told us she did her research in Greenland, but there had been a period of, I think it was a conference for like 3 days where they sat around and different experts they sat down and basically argued whether or not Greenland should be considered part of North America or not. I know this sounds like, what's the big deal? Why is it important if Greenland is or is not part of sorry, did I say United States, part of North America? But politically speaking, it can be a big deal. And again, this is going back to regions, and it's not just what's in history books or social studies books, but different approaches about, personal defense for countries or economic strategies as well. So this region in general is very resource rich, not necessarily per se as we'll see with some other regions regarding fossil fuels, but in general, we're a very resource rich region. We've seen major human transformation across this area, across the land, especially in the United States. This is one of the world's wealthiest regions. Even if you're thinking, I am so poor, I don't know how I'm going to be able to buy my beer next week. We are one of the world's wealthiest regions. We are one of the highest consumers of natural resources in the world. Actually, I shouldn't say one of. We are the highest consumers of natural resources in the entire world. This is 2 highly urbanized, mobilized populations, again, Greenland being excluded from that, and the U.S. hegemonic force, which is a global superpower for economics and politics. Another characteristic is that we are in a post-industrial economy. So you can see here for this week, your map quizzes ask you, have to remember all of them, states, this is states and provinces, so states of the US and provinces of Canada. This is the only region where I will actually ask you to do the states and the provinces. But then again, if I ask you just to label the countries, the quiz will be done in like, 0.5 seconds. And then I think I asked you waterways or something. There's one other question, one other one I think I asked you about. Oh, every time I do this, I get stuck on the first one. Okay, so physical geography of this region. You can see we've got the Rocky Mountain ranges, we've got the Cascade Range, we've got the coastal ranges, we have the Sierra Nevada mountain ranges, goes all the way, sorry, I jumped around me, goes when I don't want it to go, and it doesn't go when I want it to go. So Rocky Mountains, again, a lot of these mountains, they are separate ranges, but they look like they extend all the way up here, all the way across the western seaboard. We have the Great Plains. You have another minor mountain, well, they're not quite minor, but they are, especially when compared to the western mountain ranges. I'm not going to spend too much time on this. I tend not to spend too much time over the basic characteristics like this. Your book does quite a bit. So it's just some patterns of climate and vegetation. We've got cooler continental interior. It's a boreal forest. High latitudes, what we call tundra. Drier continental climates. And then we have very coastal influenced regions, maritime climates as well on the coast. This is interesting for a lot of people who aren't aware how big and expansive this is actually. The Great Basin Desert goes all the way up and covers even this whole section of Oregon, part of Idaho. This is something that we don't really associate with being desert-like, but it is. And then we've got, so these are complex highlands, which are mountain ranges. We've got a humid subtropical without dry season and hot summers, even though you're thinking if you happen in any of these regions, the humid seasons aren't quite that bad. Rainfall, you can see it's pretty much characteristic rainfall throughout most of the region. There's some regions down here where it's quite low temperatures because it's all in the north. Again, we see the same influx over summer, which is not a big surprise. Okay, what I would like to spend a little bit more time on for this chapter is talking about vulnerability and environmental issues, and vulnerability especially regarding issues such as climate change. So because this is a region where we have not had nearly as much time to cause landscape change as they have in Europe, yet we have quite considerably changed our landscape. So it's very characteristic of diverse physical and human geographies. You can go back and see how, again, this is a very vast region. The human component of here is also very quite diverse. We're seeing huge impacts on this region from natural disasters and huge impacts on natural disasters. And we would say many of these quote unquote natural disasters are not that natural. So when we talk about Hurricane Katrina, for example, the superstorm, or what in some places was Hurricane Sandy, while these are natural disasters, another component is that, you know, look at Hurricane Katrina, we took away the wetlands. We took away the marshes. We took away nature's natural barriers. The same thing when we look at the Mississippi flooding. A lot of our rivers that flood, we talk about, well, these are natural disasters, the 100-year flood. But part of the problem is that we have so thoroughly altered and changed the landscape and the environment that we've taken away nature's natural barriers. We've created dams in places where, you know, maybe for flood control, but they can only control so much. And then we create further potential dangers for human populations that live in those areas. So we would say, and we would argue, that a lot of the quote unquote natural disasters are not that natural. It doesn't mean that humans have created the hurricanes, have created the flooding, but climate change being part of this is that we have influenced these natural disasters to be much bigger, much stronger than they would have. And we're also putting human populations in areas where realistically we shouldn't be living. So the cost of human modification. So these are just some of the costs and the impacts of human populations in these regions. So we've seen transforming soils and vegetations, and I'll show you another one where you can see to the extent that we have seriously altered the natural landscape. In transforming soils and vegetations, this is also, you know, down here at the Gulf of Mexico, we have a big area, it's called a dead zone. It's at the base of the Mississippi River. And this is basically because of the pesticide and the fertilizer use that gets washed down into the river, that gets washed down here. We've created this huge dead zone because we're putting so much nitrogen and other chemicals into the water. Well, the fertilizers then also cause an influx of growth in the water of different algae, which then basically suffocate all of the species in the water because they have used all of the oxygen. This is a growing problem, not just here, but we're talking about this region, right? And then the chemical runoff can cause other problems as well. Hundreds of years or decades and decades of intensive agricultural practices also contribute to soil and vegetation transformation. Managing water, especially in the aqueducts that exist below the Midwest, we've seen huge amounts of groundwater depletion because basically we are using the water at faster rates than with which it can be naturally replenished. This is not sustainable. Nuclear waste storage, I'll show you another picture of this later on. Chemical spills are a huge issue. These are just some of them. The list can go on and on. And then we've also seen altering the atmosphere. So creating urban heat island effects. If anybody has been in parts of Honolulu, New York City is another great example, where in Manhattan on middle of August, middle of summer, it is much warmer than if you were in a park somewhere else. In the same region, right? So we've created this urban heat island effect where basically the heat bounces and it is absorbed by the concrete. And you can see the same thing when we're talking about different places. If you're walking around in the summer here on Oahu versus even another island. Acid rain is another big impact. The purple areas are all areas affected by acid rain or acid precipitation, and this is largely related to our use of coal in the country. And we'll talk about this a little bit more when we get to Europe. But anyway, so you can see here, you can follow this. Your book has the same maps. You can see the drought that has been caused, wildfires, growing wildfires, another quote-unquote natural disaster that's not that natural. You see threatened coastlines due to erosion. Erosion is often then also related to human impacts and overmanagement of coasts. So we can see a lot of areas are quote-unquote vulnerable to sea level rise, coastal pollution. What else do we have up here? And then desert and desertification are also more issues. So the percent of natural land cover. So if you look at this, the red areas are National Park Service units. So those are declared protected areas or national park, not necessarily just protected areas. The blue are U.S. Fish and Wildlife Service refuges. So there's a decent amount. Would be nicer if there were a lot more. It looks like there's some states that I'm not sure if they have any except for minuscule little dots here and there. So then we're talking about so these are based on counties. So this is how much of the land of the natural land cover still exists. So the red means less than 10% still exists. Yellow means 10 to 60%. This is a huge range. It might only be 10%. It might be 60%. Green is 60 to 90%. And then the bluish color is more than 90%. However, if you remember back from a couple of lectures ago when we talked about population density and population distribution, you should be able to see the clear correlation here that a lot of the blue areas are also where there's very minimal people living. So again, there is a very clear correlation that the less people are living there, and it's not just the less people are living there, therefore, there's also people don't want to live there, or people can't live there. Like physically, it's very difficult. There's lack of natural resources, lack of water, for example, lack of access to electricity. So there's also reasons why people have settled where they have settled. So you can see here at least 50% of the United States has, let's just say the yellow is put it at 40%. So a great majority of the United States, more than 50%. This is not taking into account Hawaii and Alaska. That would greatly change this, the amount of land cover. But you can see that the majority of the United States, we have altered the natural land cover. Nuclear waste storage sites, most people are not aware of this. So these are nuclear waste locations in the United States. So a lot of these are government maintained or I will point that none of these sites are actually where they really are. It actually does sound that markers are not precise locations. I do know where some of the more precise locations are in Oregon and Washington, and they don't put those there. They never release, online the actual location of them because they don't want people to go and potentially attack them. But you can see, so these sites store spent nuclear fuel, high-level radioactive waste, and/or surplus plutonium destined for geologic disposal. What that means is something else, right? And it says, as of now, Yucca Mountain does not store any nuclear waste. So 1 out of all of these 77. And a lot of these might have been built a long time ago. There are issues with leaking. There's also issues of how do we move these without causing more leaking. So it doesn't mean that these are highly protected and safe sites either. So water use. This is the Colorado River. You can see we have dammed the Colorado River. I did a case study on this a few years ago. Give you a nice picture down there of naked people trying to save the Colorado River. Basically, you can see here on the top right, on the top left, so you can see where the Colorado River comes from. So the blue, the different reservoirs, and then it comes down. It's supposed to arrive to Mexico and go out into the Gulf of California. That doesn't happen very often. It passes through several states as well as, it's talking about its tributaries. So we've got Wyoming, Colorado, Utah, New Mexico, Arizona, Nevada, California, and then it comes down, I think I said Arizona, it comes out through Mexico. So you can see here part of the large dams that have been created. You can also see, so this is where the water previously would have been. So this is a backed up reservoir, and now it has gone down a lot. So there's 5 major problems associated with the Colorado River. So the Colorado River Basin includes some of the driest lands in the United States and Mexico. For its size, for this size of river, It only has modest flows, yet we expect the river, you can see on the bottom right down there, as well as the bottom left, this is the river that is supposed to be making its way. There's obviously infrastructure built to get cars over the river. There is, you can see this river is not reaching where it's supposed to be reaching either. So there are legal pacts that dictate, which is up here on the top right, which is from the Bureau of Reclamation, and this shows what they estimate the annual allocation in acre feet to be. So the upper basin states are supposed to get 7.5 million. You can see Colorado, New Mexico, Utah, Wyoming, and the lower basin states are supposed to get the same amount. California, Arizona, Nevada, Mexico's supposed to get 1.5 million for a total of 16.5 million acre feet. The problem is the river rarely ever gets that much water. So the legal pacts were signed in 1922 and 1944, allocating more water for human use in the United States and Mexico than the river can actually supply, even when there is no drought, even when they quote-unquote have normal rainfalls. And it allocated no water for environmental purposes. So the animals, the plants that rely on the ecosystems that are fed by these waters, none is left over for them. So since 1960, the river has rarely flowed fully to the Gulf of California because of reduced water flows. And again, this is largely by the creation of dams, because of increased water withdrawals and prolonged drought. And it's a really interesting system that we're not going to go into too much here. But so, for example, if we go back to the previous one, you can see these upland states. So California, for example, is supposed to have, where's California? 4.4 million acre feet. Now, if they don't receive 4.4 million acre feet, they can go ahead and they can sue Colorado, for example. They can sue some of these other states. Now, part of this is that this pact was created based on water calculations that happened during a year where there actually was substantial flooding. So these numbers were based on estimates of a rainfall and a water level that has never been achieved again. There's also a lot of pollution that is related to this water system as well. So just to kind of sum it up briefly, and you can see here, this was a riparian habitat. So it's like a quote-unquote marsh, you could say, if you're not familiar with the concept of riparian. On the left is what it looked like in 2013, and on the right is what it looked like in 2014. So basically, is what we've seen happen is that there was a restoration of it. Dams, this has been somewhat characteristic of the Klamath River as well in Northern California and Southern Oregon, where there have been reclamation projects to try and recover water for the environment. Usually a lot of bird species are very dependent, not just aquatic species. But there's a lot of variety of species that are also dependent upon these water systems that need the water to live, to survive, not just, aquatic species. But then again, this comes down to a constant battle between the humans and nature. So a couple other things regarding environment. So we've seen a huge growing environmental awareness in the United States. The modern environmentalist movement actually happened in the 1970s, but it is believed to have stemmed from this book that was published in 1962 by this woman named Rachel Carson. The book was called Silent Spring. I don't know if anybody's read it. If you haven't read it, I highly recommend it. It's actually a really good book. She was a biology teacher, I believe high school. She died, if I'm not mistaken, right before the book was published, of breast cancer. But she had basically observed that, and she'd been working on the book for a long time, but before this, basically we use this thing called DDT. Cannot remember specifically what DDT stands for. Let me see if it's in here. We just call it DDT. But DDT was a great product to fumigate and to spray, and it is still used in a lot of countries. We actually make it, even though there is an international ban on it, we as in the United States, and we export it to Africa, where it is used to treat malaria. But it was believed at the point that you could use DDT in anything and everything. The part of the problem is that DDT, it doesn't decompose, we could say. It doesn't break down, or it breaks down. It's a very persistent pesticide. and it doesn't just evaporate and go away, it stays. And A, it can make people sick, but B, it doesn't break down, it stays, it gets into the waterways, and then it is absorbed into phytoplankton, it's absorbed into algae, and then they would find that small fish eat those items, and the larger fish eat the smaller fish. So the same thing, I think you're probably getting me here, that they say don't eat tuna fish more than a couple days a week because of the high mercury content, which has been the same as this bioaccumulation. Then it finally became a point where people actually listened, and we started seeing the change because all of a sudden bird populations were dying. And more importantly, the American bald eagle was dying because the chemical was the DDT was in the body, and it was affecting the reproductive cycle of the birds. So basically the nests, the eggs they were either infertile, or the shells were so thin, because this is what the chemical was doing to the animals. The chemical was so thin that the the baby birds couldn't survive long enough to hatch. So we've seen a huge drastic decrease. There was this huge campaign, and this woman was just, she'd been working on this for quite a while, and she was written off as this crazy woman. Think about the times. She should just stay home. She shouldn't be working. She shouldn't be meddling. There were death threats against her. And the concept of Silent Spring was that there weren't any birds. We got to spring and there weren't any baby birds. It was quiet. And spring is not supposed to be quiet. Spring is supposed to be full of birds chirping, the sounds of spring, right? So this really kicked off the modern environmentalist movement, which again really started in the 1970s. This is where we've seen, most of you have grown up at least with the concept of recycling, at least the pop bottles and paper, which there's a lot of issues with that, but that aside. And we also saw around the same time, we saw the initiative of a lot of environmental policies that were created in our country, such as the Endangered Species Act, which was passed in 1973. You got the Clean Air Act in 1970, followed by 1990. There were a bunch of other environmental acts as well, and also with the creation of the Environmental Protection Agency, which was created in 1970. And then through this, you also start to see a movement of sustainable agriculture, which then goes against the concept of GMOs, which are genetically modified organisms. So your book talked about this quite a bit more too. So the shifting energy equation, how do we get our energy? So this shows you in the United States. This book I know it's North America, but most of the information they provide is actually, it's very US centric. So our energy consumption, you can see how we had wood for a while, and then coal started being used. Coal was quite substantial. A lot of people still want to think that coal we don't use, but you can see that we use more coal today than we did 70, 80 years ago. Natural gas came on the scene about 100 years ago. You can see natural gas really started spiking about 1960. It was growing. 1970 it spikes, and it's continued to use petroleum. So, other fossil fuels, petroleum-based crude oil fossil fuels. It spiked there in about 1980, went down, and then has continued to grow up. Nuclear power. So again, we don't get necessarily a lot from nuclear power, but it's continuing to grow. And then hydropower, geothermal, and other. Again, a very small percentage. So you can see where there has been a slight increase. Any of this previous purple was really dams. So you can see we haven't had a huge increase in probably the last 30, 40 years regarding nuclear power and regarding geothermal, but at least it's persistent. And a lot of this is not just, it's also an increase in demand as well. Fracking, we talked about fracking a little bit last week, so I'm not going to talk about that again, which is a controversial practice that we do use here in the United States. So high energy consumption. One of the things we talked about in the first slide was that United States particularly, we can't really clump Canada in with us. We have the highest energy consumption in the whole entire world. So 2014 US net generation by energy source up there in the top left. You can see where we're getting all of our energy from. The majority is still coal. And this is not that long ago. You might be thinking, well, because you've heard anything with the Trump presidency, there's been, we're going to bring coal back. Well, there's still a lot of coal, and we know coal is really bad for the environment. So how is that happening? Um, and this is not for automobiles. This is just for energy consumption, right? Natural gas is a big one. Nuclear. Anybody know how we produce our energy here on Oahu? There's a lot of solar panels, but the majority of our energy actually comes from petroleum liquids. And let's see, so energy use per capita down in the bottom left. So this is divided per person. The US is highest, followed by Russia, France, Germany, Japan, UK, Italy, China, and yeah, Canada's not even on there. They might have skipped over Canada. I don't think they can put every country on there. But you can see our energy consumption is much higher than any other nation. So 2007 was a little bit before that. Electricity consumption. So this is more from a concept of a nation rather than an individual in this perspective. So this is not per capita. So if you look on the left, China's 2,000. We're 7,000. They're basically less than a third of what we use. Whereas if you just look basis on the country, China's pretty close to us. So we know there's a lot of probably industrial activities that are going and influencing the consumption of electricity. And then I give you a link here for Gapminder. We'll probably use this again later in the semester. But I highly recommend going, and you can check this out. They've got, go to the page, you can go to Gapminder Tools, and they'll show you you can pick different factors. You can see, for example, GDP and electricity consumption. And you can see how the GDP, so you're kind of looking for correlations between different factors, how energy consumption has changed over time. And at the same time, you can do it like on the X versus the Y axis. You can look at how this relates to as well the GDP growth of a country. So usually as countries are quote unquote growing and developing, industrializing, their energy consumption is going to continue increasing as well. So I think this is always really interesting. This gives us the countries with the same annual energy consumption as each US state. So here in Hawaii, we have 1 million people, roughly. We use the same amount of energy every year as the country of Panama, which has many more than 1 million people. The state of Texas uses the same amount of energy as the entire country of Brazil, which is a pretty big country. Not just size, but population-wise. And you can look for your state and see how you compare. I wonder. And then we've also got the levels. So for example, Montana, energy consumption is pretty low. I keep saying Brazil. Texas is the highest, followed by California, it's really hard to read these without reading the states. But yeah, so you can see, and then comparatively speaking, in Hawaii, we are like 0.5 to 1, whereas Texas is like 10 to 15, and this is based on quadrillion BTU. BTU stands for, it's back here somewhere, I can give it to you, British thermal units. I'm not that great at chemistry and physics. Okay, so climate change. This is something we'll talk about with every region as well. So what we're seeing here in North America is more extreme temperatures, not just hot, but also cold, more extreme levels of precipitation. So this could be low extremes and high extremes, droughts as well as flooding. Varying regional patterns. So different things are happening in different regions within the United States, within Canada. You might see sea level rises. This is one factor here. We'll also see coral bleaching. We'll also see increased rainfall. There's a lot of potential factors that we'll see here that might not be directly related to climate per se, but indirectly related. Coastal erosion is another factor that we'll see here. Glacial retreat, obviously not something we'll see here. But there's a lot of factors that are happening all throughout the country. Another factor we're seeing here is on the right, we've got access to the Northwest Passage. So this northern area used to stay frozen all year long or possibly open up for brief weeks in the summer. And now they're finding that you can actually get through the Northwest Passage um, throughout several months of the year, which is now creating, you named it, cruises for people to go traveling from New York to Anchorage, Alaska through the Northwest Passage. I am sure it is absolutely beautiful, but cruise tourism is also one of the most ecologically devastating forms of tourism as well. On the left, we have Mount Hood. This is the Elliott Glacier. On the bottom, you can see this is actually one of the few places that you can ski year round. It's the same exact glacier. On the bottom, we've got a picture from August 1901. And in the top, we have a picture from 2 years ago. It might not look like a lot, but this is a lot. So this glacier receding as well. Finally, I think it's the last one. We've got U.S. climate change impacts. So this is kind of like the perception map. This is how they believe how each state is being most affected by climate change. So Washington, we've got salmon loss, wildfires, coral bleaching here for Hawaii, Zika for Puerto Rico, future archipelago. It's probably true. Florida is estimated to be mostly under sea level. Heat waves for Texas, intense drought. Better than probably, what was it, fake boobs and oranges? But anyways, so you can see a little bit different characteristics of how, and here actually more snow, look up at Michigan. So climate change will influence each region quite differently and distinctly as well. So anyways, that is the end of part 1. Thank you for joining me. Let me know if you have any questions and have a great week.